Imagine thinking about moving your hand and a robotic arm across the room moves instead. No muscles. No nerves. No words. Just a thought. What sounds like science fiction is happening right now in labs around the world. Brain-computer interfaces, BCIs, are erasing the line between mind and machine. And Elon Musk isn't the only one trying to get inside your head. A brain-computer interface is exactly what it sounds like, a direct link between your brain and a computer. Your brain runs on electricity. Billions of neurons fire electrical impulses, and every thought, every movement, every memory is fundamentally an electrical pattern. A BCI reads those patterns, translates them into code, and sends them to a computer. Or the other way around, the computer beams signals directly into your brain. There are 3 types of BCIs. The non-invasive kind, those caps with electrodes you wear, like an EEG at the hospital. Safe, but the signal quality is terrible. It's like trying to understand a conversation through a closed door. Then there's the partially invasive version, electrodes placed on the surface of the brain, under the skull but outside the tissue. Better reception, but still plenty of noise. And then there's the invasive approach. Electrodes implanted directly into brain tissue. Threads thinner than a human hair, placed with millimeter precision into specific brain regions. That's Neuralink's method. And that's the technology that's about to change everything. The story of BCIs didn't start with Elon Musk. Back in the 1970s, researchers were already decoding signals from the motor cortex of monkeys and using them to control robotic arms. But the technology was crude. Thick cables, bulky connectors, and infection risks that made long-term use impossible. The big leap came in 2004. A paralyzed man named Matt Nagel received an implant called BrainGate. He could move a cursor on a screen just by thinking. He played Pong. He opened emails. All with his mind. For the first time in history, a human had controlled a computer directly with their brain. Then 2021. Neuralink released a video that went viral. A monkey named Pager was playing the video game Pong, no joystick, no keyboard. Just his brain. The Neuralink chip in his motor cortex was reading the neural signals that would normally move his hand and translating them into game commands. Pager thought move up, and the paddle moved up. And 2024 brought the moment everyone was waiting for. Neuralink implanted its first human patient. Noland Arbor, paralyzed after a diving accident. With the implant, he could play chess, grind civilization, and control his computer using nothing but his thoughts. He said it felt more intuitive than any mouse or touchscreen he'd ever used. It feels like using the Force from Star Wars. But how does this actually work? Let's look inside the Neuralink chip. The N1 chip is about the size of a coin, 23 millimeters across. It's implanted by a surgical robot that's more precise than any human surgeon. The robot avoids blood vessels, selects the optimal entry angle, and places 64 ultra-thin electrode threads, each thread with 16 electrodes, into the target area with surgical precision. That's 1,024 electrodes recording simultaneously. The electrodes measure tiny voltage fluctuations in the microvolt range. These analog signals are digitized inside the chip, filtered, and sent via Bluetooth to a computer or smartphone. All in real time. And the chip charges wirelessly like your electric toothbrush. No cable dangling out of your skull. The real magic happens in the software. A machine learning algorithm learns which neural patterns correspond to which intention. The patient imagines a movement, say, moving their right hand upward. The system sees the neural firing and associates it with that movement. After a few training sessions, it works almost as intuitively as a real muscle. And here's the incredible part: the brain adapts. It learns to communicate with the implant, optimizing its signals. Neuroplasticity in action. Neuralink is the poster child, but the competition isn't sleeping. Synchron, an Australian-American startup, takes a clever shortcut. Instead of opening the skull, they thread their electrodes through blood vessels like a stent. The electrodes end up in a blood vessel right next to the motor cortex. No open brain surgery required. The procedure is minimally invasive and has already been tested on over 10 patients. BlackRock Neurotech has evolved the BrainGate system and